Welcome to the lecture of Power System Operation and Control. Myself, Professor Gaurang Patel. Today we will going to learn about the chapter 2, that is Power System Security. So these are the contents of this lecture. First of all, we will begin with the introduction, what is power system security. Then we will see what is the system state classification, then the security analysis, and then we will see what is the contingency analysis. Okay, so one by one I will explain you all the topics and see uh, what things are come into the lecture. So we know that the power system is a complex network which is consisting numbers of equipments like generators, transformers, transmission lines, circuit breakers, etc. And failure of any of these equipment during the operation of the network, it will be cause an unreliability of the system. Okay, so we have to make sure that thus one of the major agenda of power system planning and its operation is to study the effect of outages in terms of its sensitivity. But we know that power system being dynamic in nature does not guarantee that it will be 100% reliable, and hence a detailed security analysis is required to deal with the possible failures in the system and its consequences. So in its remedial actions, this analysis is known as a power system security analysis. If you want to give the definition of power system security, that means power system security may be defined as the probability of the system's operating point remaining within acceptable ranges and given the probabilities of changes in the system and its environment. Okay, so the power system security involves system monitoring where the real time parameters of the system are monitored by using the telemetry systems or by the SCADA systems. Okay, so basically what we can say, so whatever power we are going to produce, it should be we can transmit those power in reliable manner to our consumers. Okay, and this is the responsibility of the electrical engineers. Then it can be delivered to our consumers with reliability, okay, and with the security. So that's why we must have to know each and every parameter and which at which the power system can operate it is securely. So all those factors are considerable in the power system security. Okay, so here we will start with the this question that is asked in examination, in GTO examination, that is explain major three functions of a power system security and system state classification. Okay, so in that we will see which are the three functions that is really an important functions with regarding the power system security. Okay, so first of all, when we are seeing here, that is Dr. Liako first pointed out in 1967 that a power system may be identified to be operating in a number of states. Okay, so he distribute it is in a three states. That is, first of all, it is a preventive state, and the definition of that preventive state, it is given as the preventive state is actually the normal term that preventive was used to stress the security aspect of the normal operation. Okay, so we will start with the preventive state. In preventive state, what it is says that normal operating condition usually means that all the apparatus are running within the prescribed limits and all the system variables are within the acceptable ranges. So that means whatever the equipments what we are going to use in the power system, that should be used in that prescribed limits. It should not be exceeded the limits. So if it exceeded the limits, it will create a problem for the power system security. Okay, so he will define these three states, and this is the figure you can see here of the that three states, that preventive state, emergency state, and restorative state. Okay, so these are the three states that you can see in the figure, and it is pointed out with the operating states of the power system. These are the operating states of the power system. Okay, now we will see that in next session the system should also continue to operate normally. Even in the case of credible contingency, the operator should foresee such contingencies and take preventive control actions such that the system integrity and quality of power supply is maintained. So whatever the problem is arise, the system should not be stopped, its power quality should not be compromised, and the power should be supplied with the reliable manner. Okay, that is considering in the first state, which is we discussed, that is the in preventive state. Okay, now in second term, that is the emergency state. Now that word suggested itself, if some of the emergency is came, so what would be the uh, position of that particular area or particular state. Okay, so for the emergency state, the power system enters an emergency state when some of the components operating limits are violated. Okay, so if the as we discussed, if the components ratings are violated, or it is not operating in such a manner that the system can be operated normally, so it will be create a problem. Okay, so some of the states when the outside the acceptable ranges, or when the system frequencies start to decrease. Okay, so in emergency state such kind of things are happen. Now when you see, the control objective in the emergency state is to relieve system stress by appropriate actions, and economic consideration become secondary at this state. So in emergency state, your economic consideration is become the secondary state. The priority you are given to the security of that whole power system and security of all the equipments which you are going to use. Okay, and in third state, that is the restorative state. So in restorative state, you can say restorative state is the condition when some parts or whole of the system has lost power. So it is the state after those two states are going to be over. So restorative state, in restorative state the system is going to be try to recover itself. Okay, so the control objective in this state is to steer the system to a normal state, again by taking appropriate actions. Okay, so these all are the states which we are considering here. In that we will see over here. So I hope now you can understand what are the three states of the power system security. That is what considering in the preventive state, what is considering in the emergency state, and what is considering in the restorative state. Okay, in summary, if this question we can say that the in preventive state we are trying to prevent to create the problems. Okay, but if it is not happen, or if situation is become worse, then we are entering into the emergency state. Okay, so in emergency state, what is the priority? We have to secure the system, that is the priority of the system. And then after this, restorative state is come into the picture. And in restorative state, if something happens abnormally or something operates abnormally, so in restorative state it will be cleared it out, or you can say that our power system is going to be restored in that particular state. Okay, okay, now we will see one more question which was asked in winter 2017, that is define various operating states of power system and nature of various control actions and their significance. Okay, so over here we can see that to understand the above functions, we will first understand what is the question, that is define various operating states. So first of all, we will discuss the various operating states of the power system and nature of various control actions. Okay, so the according that these are the various operating states that we were discussed earlier. Okay, so in last question, these are various states are discussed, and over here this is the control actions which we are going to take, that is optimal dispatch, post contingency, secure dispatch and secure post contingency. These all actions we will understood through the figure, what is the optimal dispatch, what is the post contingency, what is the secure dispatch and what is the secure post contingency. Okay, so here we will start with the first one, that is the optimal dispatch. Okay, now if we will look at some of the definition regarding the optimal dispatch, it is the state that the power system is in prior to any contingency and it is optimal with respect to economic operation, but it may not be secure. Okay, so in first, if we discuss for the optimal dispatch, so it is the state that power system is in prior to any contingency, and this will also we will discuss with the figure as well, so you can understand it very well. So first of all, we will discuss the whatever the definition of the optimal dispatch and what are the definition of post contingency, then secure dispatch and then the secure post contingency. Okay, so over here it is the post contingency. So it is the state of power system after, in post contingency you can see that, okay, in post contingency you can see that it is the state of the power system after contingency has occurred, and we shall assume here that this state has a security violation transmission line or transformer outside its flow limit or bus voltage outside limit. And in secure dispatch, it is the state of the power system with no contingency outages but with correction to the operating parameters to account for a security violation. And for the security post contingency, it is the state of the power system when contingency analysis is applied to base operating condition with corrections, and it is illustrated with an example. Okay, so all those situations are illustrated in example. We will start with the first, it is the optimal dispatch. Now in this figure you can see over here there is a two generators over there. In that figure you can see there is a two generator, one generator is having a 500 megawatt load and one generator is producing the 700 megawatt. Okay, and there is a transmission line is connected in between two buses. So two generators are connected at two buses, one is of the rating of 500 megawatt and one is the rating of 700 megawatt, and each transmission line over here, that is carry the 250 megawatt load. Okay, so in optimal dispatch what we can see over here, that is the 1200 megawatt, this is the symbol of load. So total 1200 megawatt load is there. So we can say that it is the optimal dispatch. That means our transmission line is carried with, or it is operated with its full capacity. Okay, so 250 megawatt and this 250 megawatt, this is the 500 megawatt and generation is 500 megawatt and transmission line carry the power of the 500 megawatt and total 1200 megawatt reach to that particular load. Okay, so we can understand from that in optimal dispatch all the network or all the transmission line and generator connected to the power system, it will operated at its full efficiency or it will operated at the optimal state. Okay, now in next case over here we can see these all are the things that I already discussed with that figure. Okay, so this is the next case for the post contingency. Now over here you can see in post contingency what happened, one of the line is over here, that is we consider in a outage. So this line, suppose it is in outage line, so these two transmission line as we show in previous figure, both are carried 250 megawatt and one of this line is going to be outage. So only one transmission line has to carry the 500 megawatt load over here. So what happens, this one transmission line is going to be overloaded. Okay, because the load demand is same over here, that is the 1200 megawatt and one line is outage. So that 250 megawatt that carry previously this line, it will be transferred from this single transmission line and this transmission line is become the overloaded condition. So it is the post contingency scenario when this kind of situation is occurred. Okay, and this is the theory that it explains those things. It says that figure shows the post contingency state. Suppose one of the circuits making double circuit lines is open due to the failure. The circuit will be as shown in figure below, that there is an overload in the remaining circuit. Okay, now we will see how we can be take care of that, or how we can prevent our power system with such kind of situation or with such kind of conditions. Okay, so for that condition, what we have to do, we must have to take care of that contingency analysis, and we have to must secure that if any outages happen, we have to take some measures before the outages happen. So in that figure you can see, in secure dispatch, what we are doing, we are try to, this generation is going to be reduced from 500 megawatt to 400 megawatt. So and this is 800 megawatt, it remains 800 megawatts. Okay, so that's how we can make all this situation in under control. Okay, now over here you can see, if we don't have this condition to arise, and we shall correct this by lowering the generation on unit 1 to 400 megawatt. That what we are discussing right now. Okay, now here you can see it is the secure post contingency. From that you can see, if one of the line is outage over here, so what we are doing, we are just limit the generation, or put the limit on the generation, or reduce the generating capacity of that particular generator, and reduce the load of that particular transmission line which carry the all the power through that load. Okay, so here there is the figure for the secure post contingency, and what is the theory it is included. Now we will discuss the theory, what is included. Now if the contingency analysis is done, the secure post contingency is shown in figure. Thus, by adjusting the generation on unit 1 and unit 2, the post contingency state is prevented from having an overload condition. Okay, so the program which make control adjustment to the base or pre contingency condition to prevent violation in post contingency conditions are called security constraint optimal power flow. So this is also known as a scope. So such kind of questions if asked in examination for related to contingency analysis. So I hope you are able to understood this answer, and I hope you can able to give the answer in the examination as well. Okay.